Okay, welcome back. We are continuing our look at rational exponents, what it means to have a fraction like 1/2 or 1/3 as an exponent here. If you recall, at the end here, or at the start of the last video I should say, we looked at the lesson summary here where we learned that when you have a fraction for an exponent like 1 over n, it becomes a root. The denominator there, n, becomes the root of the base. If you have a fraction with a numerator and denominator, that's a numerator not 1 over n, like m over n here, m becomes the exponent of b, and n becomes the root. So the numerator becomes the power, the exponent there, m becomes the root. Okay, and there's two different ways you can write it, and they're both equivalent. So you can put the nth root on the outside with m on the inside, or you can put the nth root on the inside with m on the outside. And of course, if you have a negative, it still follows the same properties as before, where it goes in the denominator like that. 1 over our answer. So let's do some more here. Okay. So example exercise 2, 3 to the 1/2. We're just going to rewrite this as an nth root. So we can see the 2 is the denominator there, so that's going to be our square root. And we just put a 3, and you can do 3 to the 1 if you want to, or you can just write 3 because it's the same thing. Of course, you could also just write square root of 3 too. These are also equivalent. Okay, go ahead and try 11 to the 1/5. Pause the video, do it for yourself. Okay, hopefully you pause the video there. Your answer should look like this. 5th root of 11. Again, if you want to put a 1 for the exponent, you can, but this is fine too. Okay, go ahead and try 4 and 5 too. Okay, so for 4, hopefully you got something that looks like this. Okay, and then for 5, you should have gotten something, whoops, that looks like this. Okay. These next ones we're going to again rewrite using as equivalent radical expressions. We're going to use our radical symbols there. If the number is rational, write it without radicals or exponents. Okay, so 2 to the 3/2. So in this case, our denominator is 2, so we're going to have a square root. We have an exponent of 3, so it'll be 2 to the 3rd, like that. If you want to, you could further simplify it and say something like 8, because 2 to the 3rd is 8. Or you could also write this as the square root of 2 cubed. That's also acceptable too. So this one, or this one are all acceptable. All right, go ahead and try 7 and 8. See what you can come up with there. Okay, so 4 to the 5 over 2 should give you the square root of 4 to the 5th, like that. As one option, or you could also do the square root of 4 to the 5th like this. Now, we know what the square root of 4 is, so we really could simplify this even more. The square root of 4 here is 2, so we're going to really do 2 to the 5th is our final answer there. Or if you like, you can do, what is that, 32, I think? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, yeah. So that one actually simplifies nicely. This one not so much because we don't really know the square root of 2 very well. Okay, finally 1/8 here. We can do that as the cube root of 8. Whoops, the cube root of 1 over 8 to the 5th, like that. Or, again, we can flip around and do the cube root of 1 over 8 to the 5th. Now, this also we can simplify further, okay? When you cube root 1/8, it's like doing cube root of 1 over the cube root of 8, and that's still to the 5th power. What's the cube root of 1? It's 1. What's the cube root of 8? It's 2. I raise that to the 5th, we get 1 over 2 to the 5th, or you could just say 2 to the negative 5th if you wanted to, or you could say 1 over 32. Okay, so lots of options there. All right. Let's continue on here. Show why the following statement is true. Okay, well, I mean, we could just, again, multiply both sides by 2 to the 1/2. Okay, those will cancel. We'll have a 1. And when you multiply, you add your exponents when you have the same base like this. So we'll get 2 to the 1/2 plus negative 1/2, which is 2 to the 0, which is in fact 1. So check, that works. Okay, and now we're going to rewrite the exponential expressions as equivalent radical expressions. Okay, so similar kind of thing, we just have negative powers here. So I'll show you one, and then I'll have you guys try the next couple. Okay, so now we have a negative exponent, so we want to be a little more careful here. 2 will still be our radical. Actually, let's go ahead and rewrite it this way. 1 over 4 to the 3 over 2, like that. Okay, which then, because again, it was a negative exponent, so we put that down in the denominator like that. And now we'll rewrite this in the denominator. So it'll be the square root of 4 to the third, or 1 over 4 to the third square root, like that. Either one of these is acceptable. And of course, we can square root 4 there, so we could also write or 1 over 8. Nope. Square root of 4 is 2. So it's 2 to the third, which gives us 1 over 8 there as our final answer as well. Okay, a couple options. Go ahead, try 11 and 12, see how you can simplify those. Okay, so for our last two, 11 and 12, again, we'll rewrite that as 1 over 27 to the positive 2/3. We'll rewrite this one as 1 over 4 to the 1/2, like that. Bit of a strange thing. We'll come back to that. Hold the thought there. 1 over 27 to the 2/3, we can rewrite as 1 over 27 squared, cube root of 27 squared, like that. Or we can write as 1 over the cube root of 27 quantity squared, like that. Okay, and of course this simplifies, right? So for example, right here, the cube root of 27 is 1 over 3 to the second, which is 1 over 9. So you can also just say 1 over 9, but these are acceptable too. Here for this one, okay, we'll go ahead and simplify here. So it's 1 over the square root of 1/4, which is the same thing as 1 over the square root of 1 over the square root of 4, which is 1 over 2. And again, instead of dividing by 1/2, we can multiply 1 by the reciprocal, 2 over 1. So this is really just 2. Okay? When you have a fraction with a negative exponent like this, you can actually just take the reciprocal of that fraction, so we can just make it 4 over 1 and then raise it to the positive 1/2 power. This is another option here, which really is just 4 to the 1/2, which is the square root of 4, which is 2. And you can see we get to the same answer, but a little bit faster. Okay? Thanks for watching, guys, and we'll see you in the next lesson.